I know where there's some, right here in the hall, clerk.
No, Molly, I have no.
Hi, and welcome to part 3 of the Zenith 60B chassis. This video we're going to check out what I talked about in the first video. I apologize for the long second video, but I thought there was some stuff that needed to be addressed there. In this video we're going to look at the power supply, the power transformer, and then move on from there to check out the rest of the transformers and make sure they're all in good working order as best we can. And we'll start with the power cord and the primary of the power transformer. So I've got this on the rack here. It's not a great rack, but it works just fine. So what I want to do is follow the power cord, comes in here, connects to this capacitor. This is the one I was talking about in the second video. It's this guy right here, this 0.015 microfarad. That needs to be replaced for sure. And then on to the power, the on-off power switch, which is here, down here. So we'll start by checking out the power switch, and all you do is put your ohm meter across the two leads of the power switch. Sorry, from here to here, and make sure you've got continuity when you turn it on. So we'll do that. This is the switch part, this black housing. The silver housing is the potentiometer for volume. So all we have to do to check the on-off switch is put our ohm meter right across the two leads of the on-off switch, which I will put right here so you can see it. Yeah, you can see it. And I'll connect one lead to one side and the other lead to the other side, and turn the radio on, and that should go to 0 ohms, and it didn't move. That means the on-off switch is not functioning. Doesn't mean it's broken in particular. It's just could be 30, 70, however many years old of gunk built up in there, and it might just need a cleaning. So we won't give up on that yet, but we do know that's not working. So if we took a measurement, for example, a common thing to do is to measure across the power line to check the primary, measuring across the DC resistance across the power line, without it plugged in, of course. DC resistance across the power line tells you a couple of things. One, it tells you if you've got continuity from the plug to the on-off switch. We probably do in this case, it doesn't matter. The other thing it tells you, if the on-off switch works, the other thing it tells you is the impedance, the DC resistance rather, across the primary of the power transformer. Since our on-off switch isn't working, we couldn't use the power cord to do that measurement. So our on-off switch isn't working, so we'll go directly to these 2 points on the schematic. We'll go to this end of this 49 capacitor, which is going to be restuffed actually, at some point, and then the other side will go to one side of the switch, right here, so that we're measuring DC resistance across the primary of the transformer, and that should be 10.8 ohms according to the schematic. So let's move this around and look at that capacitor, which is right. The capacitor of interest is this bakelite box right here, hidden behind the two replacement filter caps, which will be replaced. So this box right here, If we look closely enough, I don't know if I can zoom in enough. Yeah. This side, pardon my hands, this side right here of this capacitor goes to ground. This is where the bolt is that bolts the capacitor to the chassis. So that's ground, and you can see a wire coming up from the inside right there. So that's connected. So this middle terminal is used just for a connection point for one side of the power line. One side of the power line comes in here and gets connected to a wire that's back here, which we'll trace out. But this side is a function, or is a capacitor. Another way to tell if there are capacitors in here is to just measure with your ohm meter. Back out again. What you can do, let's see if I can get this in a place that I can do two things at once. Capacitors will take a charge from your meter. So if you hook the ground lead of your volt ohm meter to ground, in this case a lug on the end of this Bakelite box, that's ground. And we can prove that just by going in here and touching ground on the chassis, and you see the meter goes to 0. So that's ground. We know there's a capacitor on this end piece right here, so we'll put the voltmeter on there, volt ohm meter, and you can see it charging. The resistance is getting higher and higher and higher. The battery inside the VTVM, or the DVM rather in this case, is charging the capacitor that's in there. So we know there's a capacitor in there. If we touch our DVM to the middle one, nothing happens. It's neither grounded nor is it a climbing resistance. It's just open. And so the fact that there's no wire coming out of the middle one, and that we don't get any change when we put our voltmeter across it, means this is just a connector. It's not being used as a capacitor in that instance. One other thing to say about the capacitor here, you saw it charging. That means it has some functionality. The good news is it's not shorted to ground. It didn't short the capacitor during its lifetime, didn't short. It's possible it's been replaced and restuffed inside the Bakelite box. Can't say one way or the other, but it's possible. However, we're going to replace it anyway because this needs to be replaced with a safety cap. Safety caps are designed to fail open only. They never fail shorted. Whereas this old one will most often fail shorted or explode. One or the other. Okay, so we've got power coming in. We've got it going to, one side of the power line is going to this capacitor right here. If we refer back to this schematic, if we can pick it up. That line is this one right here. So we've got a line coming in from the outlet connecting to this side of the capacitor. So we can put our voltmeter or our ohm meter on this side right here where this connector is on the Bakelite box right here. The other side we can measure over to our on-off switch, one side or the other of our on-off switch. So I need to move the camera again. I'll put the negative lead. There's no good reason. It could be just as easily be the positive lead. But I'll put the negative lead on the capacitor in the Bakelite box right there. And then the other lead, the red lead in this case, will go and we'll measure first of all to this side of the power on-off switch. See if we get any reading. And we do, it reads 0.1 ohms. If we go to the other side, it should be open, which it is. So this is reading right here. We're reading across the primary of the power transformer. We're reading from here. Yeah, we're reading from here to here. And it says it's 0.1 ohms. That's too low. 0.0 ohms. It is acting like the primary of the power transformer is shorted, which would be a sad bit of business. I do have a parts radio. I didn't want to break into it, but I can. But let's isolate the primary of the power transformer and measure it directly. Okay, at this point I have unsoldered the two primary leads of the power transformer. This end from the on-off switch, and this end here from the capacitor. The noise filtering capacitor that goes to ground. So there should be nothing else connected to the transformer at this point. So I'll put the ohmmeter right here. Clip on this wire and clip on this wire. 0 ohms. Well, that's a bad sign. 0.2 ohms, 0.1. Boy. That's a far cry from 10 ohms. It's called out on the schematic. I looked back through the variations on the Model 60s too, and they didn't seem to change the power transformer at all. So this doesn't bode well for this power transformer. Rats. Okay. We'll press on and see how the secondaries look. But right now it looks like the primary is shorted. Oh, I wanted to check one other thing and make sure the primary wasn't shorted to ground. So I'll just lift one lead and touch it to ground. No, it doesn't look like it's shorted to ground. So it's not shorted in the case or shorted by wire. It's just shorted. Shoot. All right. Okay, the next thing we'll check here are the secondaries. And we can check them mostly right here on the 80 tube, the rectifier, going across the directly heated cathode, which is this part right here, these two pins, will tell us if this secondary, looks like it should be 2 ohms, is okay. The tube is out, by the way. And then across the two plates will tell us if this secondary is okay. This should be, looks like about 275 ohms across both. This one is center tapped, and we can figure out, once we figure out if the whole of it is okay, we'll take a look at the center tap. And finally the heater secondary is here, and we can do that on any of the other tubes, checking the heater pins. So we'll start here with the rectifier tube, and this is a type 80, so the tube, they're not marked on the schematic, which is unfortunate, but across the directly heated cathode, it's this guy right here at pins 1 and 4. Okay, here's the socket for the type 80 tube, the rectifier. These two pins here, and you can, well, maybe you can't tell, but from my perspective, I can see that these are the smaller pins because these things are shorter, and these are the two bigger pins. And I looked up underneath, and the two bigger pins face inboard on this phenolic. So these are the two large pins. These are the two small pins. I can also trace easily this green and white wire. This goes to the field coil, so that helps me see on the schematic where we are. Here's the green and white. Here's the green and white wire to the field coil that's coming off of this side of this 5-volt secondary winding here. The windings are 6.3 volts here for the filaments of the rest of the tubes, 5-volt AC here for the heater of the 80 tube, and some hundreds of volts for the B plus supply, which is here. So what we're interested in right now, since we know we're at this pin right here of the rectifier, we can go from the heater is the big one. We can go from this big one to this big one and measure across the 5-volt AC line to see what our resistance is. And I hope you can move this a little bit. So this should tell us whether the 5-volt winding is good or not. .7, 0.6, 0.7 ohms. This is interesting. This one says 2 ohms. So it's not a flat short, but it's falling short of the resistance, DC resistance called out on the schematic. If they all fall short of the DC resistance called out on the schematic on the secondary side, I'm beginning to suspect that our primary side might be okay after all. At 10.8 ohms, we're only reading a partial ohm, if that. So I will make note of that, 0.5 ohms on the 5-volt secondary. And now to the heaters of we can check out the, well, since we're right here, we just looked at this secondary. Now we'll look at the high voltage secondary across the plates, which are the 2 smaller pins, yeah. So right here and here. See what kind of resistance we get. We should be getting, according to the schematic, around 275 ohms. Let's see what we get. Oh, 381. So that's higher than on the schematic. I'll make note of that. Okay, and then we can take a look at the heater windings for some other tube, which I will find here in a second. We'll go back to the 78 tube. It's the one in the corner here, and we can see the 2 big pins for the heater right there. So I'll connect to one, and remember the tube isn't in the socket, and that's because we're measuring the transformer. We don't want to measure the transformer and the DC impedance or DC resistance of the tube heater itself. We just want to measure the transformer. And this says 0.4 ohms. The schematic calls out for right here 2 ohms. So that's okay. We'll not declare this a disaster yet. We'll say that our power transformer might be okay. It might be okay. Then again, it might not. Can't say for sure. The next one we want to check out is up here in the upper right corner of the schematic. We want to make sure that our fuel coil is good. It should have some resistance there, and then that our audio transformer, again, we're looking at for the fuel coil, this says it should be about 1140 ohms, And the audio transformer should be 400 on one side and 0.01 on the other. Okay, the fuel coil is in here. It's in the speaker. This guy right here, Philips 32 9008-W. And the audio output transformer is right here. So we'll have to take this cover off to gain access to the wires for the fuel coil. You probably noticed before, as did I, that the speaker wires are badly frayed right there. It's a wonder they didn't short. Pretty bad shape. So I'm not sure how to. I don't want to replace these wires in particular. They're so old-fashioned looking and lovely, but I might have to. Anyway, that's for another time. Let's get this cap off here, 1/4 inch. Okay. That comes off, and here we go. The wires to the fuel coil are this one right here, this guy, and the other one comes right here. So we'll measure across these 2 points and see what kind of DC resistance we get. We should be seeing 1,140 ohms. I doubt we'll see that, but we'll see what we do see. I'll put something under that so you can read that. And it's not shorted. Oh, look at that. 1.173K. And we're calling for 1.14K. That is darn close. So that's very good. Fuel coil is good. Yay. All right, let's measure across the audio, the output transformer, which is this guy. The output transformer, this side of the primary is connected to the 42 tube, and the other side is connected to the fuel coil and the white wire that comes up from the power supply, which happens to be right here. This is the white wire, and I trace this one back to the plate of the 42 tube. So we should be measuring right across here, and if we're lucky, we'll get around 400 ohms DC resistance in this primary of the output transformer. So cross your fingers. Oh yeah, there's something. Check it out. 442 ohms. Not bad. Not bad. Okay, we're cooking with gas, as someone used to say. So we've got 440 ohms across the primary. The secondary should show as almost a short, and we can pick up the secondary right down here. This is where it goes to the voice coil. The two wires go to the voice coil right here. So it should be this connection and this one, and that should give us 0.3 ohms, 0.2 ohms. So I think that's okay. I think the secondary of the output transformer is good as well. So we are in good shape. I'm very pleased about that. The power supply transformer is a little bit in question, but I'm feeling more confident that it's okay. So we have questionable power supply, power transformer. We have a probably a good fuel coil, measures out okay. We have a good audio output transformer, measures okay. The voice coil itself is down in there, and it's part of this same measurement we'll just have to take it on faith that it, without removing these wires and measuring it directly, which I don't care to do right now, we'll take it on faith that it's working. What I decided to do to try to resolve whether the power transformer in this radio is usable or not is to bring it out and put it on my variac and my dim bulb tester, my isolation transformer, and my Tipton device. And if you haven't seen my videos before, this is my Tipton device, made after plans that David Tipton built one for himself on his channel, and I copied it, changed it physically, but it's virtually the same thing. It's cool. I like this. It's very handy. Here's the dim bulb. It's attached to the circuitry in the device. Has a master power. Well, master power is here. Powering this outlet is this switch. You're going to have this switch set for dim bulb or full power. So when I'm doing testing, it's always in dim bulb. And then it's driven by the variac, which is down here. And this display, it's got a digital display. It won't come up until the variac hits about 50 volts or so. There it is. And it tells you what the line voltage is at the outlet. It's 50 volts in this instance. How much current is flowing through it? None, because it's not connected to anything. Wattage, how many watts the whatever you have plugged in here is using up, and kilowatt hours, energy, some other stuff that we don't really care about because this display is often used to measure electricity usage, and we don't care about that. So these three, voltage, current, and power. And what you do is I'll show you what you do. I'll turn the voltage back down, power that off, and show you. So here's the radio. I've got a couple of alligator clips connected to a power line. And I won't show that to you because somebody will yell at me. But I've got the voltage coming out of the Tipton device right here. And I've got one side clipped to where the old power line was on one side of the capacitor. And then I'll clip this one to the other side. And this is actually voltage going into the radio as though it were all working. Since the on-off switch doesn't work, I've got that shorted to make it be on all the time. And I've clipped out the two added electrolytic capacitors, the filter caps, that were added to the radio at some point in the past. And all the tubes are out, because I don't want to load on the transformer. I just want to see how the transformer is going to behave when I put voltage into the primary. So now I'm all set up to put voltage into the primary. I want to measure, I want to put voltage across the primary right here. And then I want to measure voltage across each of these secondaries. This is the high voltage here, and I'll pick that up by putting my voltmeter across the plates of the rectifier socket. This is the 5 volt AC to heat the rectifier, and I will measure across the heater pins on the heater cathode, I should say pins. Directly heated cathode is correct on the pins of the rectifier tube to see if this winding is working, and then I'll pick up some. These are heater voltages for the rest of the tubes. I'll measure across a couple of pins for heater voltage on one of the tube sockets. So I'm measuring AC. There's no DC conversion going on here. This is pure AC going into the transformer, coming out, and then we're measuring AC as it's kind of distributed to the various points. But I really want to make sure this transformer seems to be working. We'll put the voltmeter across the big pins of the rectifier socket. That will tell us what the high voltage secondary is doing as we bring voltage up on the primary of the power transformer. Okay, got the voltmeter right here. I think you can probably see it. I'll reach back over here, turn on voltage, and then start applying voltage to the primary using the variac. Oh, wow, look at that. I didn't have this on. I'm used to using the auto range voltmeter, and this one doesn't auto range. You have to turn it. So we've got we don't have 50 volts going into the primary of the power transformer, but we've got 103 coming out the high voltage secondary. So that's a good sign. And our dim bulb isn't on, so that means the transformer is not shorted. It's not behaving like a short. Let's run this up to 50. I don't feel a need to go all the way to 120. I just want to get a sense of whether it's working. Okay, so at 53 volts going in, we've got 143 coming out the high voltage winding. So very nice. Now I'll move the voltmeter to across the, I should say, that was being measured across these two plates right here in the socket. Now we'll go to the small pins and see if we can pick up, it won't be that high a voltage, but it'll be around, it'll be less than 5 volts if this is working. Okay, I finally have the voltmeter attached to the small pins of the rectifier socket. These guys right here, and that'll measure the 5 volt AC secondary on the power transformer. So I'll bring this up to about 50 volts. I always tell when you're about 50 volts because the readout comes on. Okay, we've got 51 volts going into the primary of the power transformer, and we have 1.1 volts across this 5 volt secondary. So that feels to me about right. Now we'll take a look. I'll move the meter to the heater, the tube heater transfer secondary right here. And I'll just pick that up on a tube. One that's easy to get to, which is for me this one right here. And that's showing 2.8 volts. So it appears to me that the power transformer is working. I took these caps out because they aren't tested. I don't have a clue whether they're shorted, whether they work. They'll certainly put a big load on it. Now it could be. I'll say this. It could be that the power transformer will fail when it does get a load on it, but I suspect not. What I suspect is that age has changed the DC resistance significantly, and the schematic references are no longer accurate. And I haven't done enough of these old Philcos to have any real sense of that, but from what I can test right now, I'd say we're good to go with the power transformer. We'll move forward. Okay. So, okay, maybe. Okay. The last three potential, maybe four potentially unknowns are the IF transformer. There's one here and there's one here. These two guys are known in Philcos, I think, to go bad, but we'll check them out. And we'll start with the second. Is this the IF? Yeah. Here's the oscillator. Here's the first IF. Here's the second. Right. Okay. So we'll check out the IF transformers